Hey everyone, welcome back to the channel. Today we are exploring a category that has lived in science fiction for decades, but is beginning to look surprisingly real in 2026. Personal aircraft are no longer limited to futuristic movies, as new designs are finding their way toward garages, private collections, and backyards. In this video, we are checking out 10 remarkable machines that enthusiasts can already purchase, reserve, or pre-order. From electric ultralights that resemble human-sized drones to futuristic flying bikes and compact two-seat aircraft, these designs combine electric propulsion, intelligent flight assistance, and compact dimensions to make private flight more practical for recreation, short journeys, and pure adventure. One of the most dramatic new entries in personal aviation is the Volonaut Airbike, created by Polish inventor Tomasz Patton. Designed as a jet-powered hoverbike, this extraordinary machine looks like something pulled directly from a science fiction blockbuster. Instead of conventional exposed rotors, it uses redundant jet propulsion integrated into an extremely open carbon fiber structure, creating a cleaner appearance while eliminating large spinning blades around the rider. Advanced carbon fiber materials and 3D printed parts keep the empty vehicle at an astonishing 30 kilograms, roughly 7 times lighter than a conventional motorcycle, helping explain its impressive agility and responsiveness. Prototype flights have reportedly reached speeds of up to 200 kilometers per hour, although the United States FAA ultralight compliant configuration is restricted to approximately 102 kilometers per hour. Behind the scenes, redundant flight computers manage hovering and stabilization while translating rider inputs into immediate control adjustments, allowing even less experienced pilots to enjoy a completely open 360-degree view as they move through the air. Its extremely compact design also gives it access to narrow clearings, forest routes, and confined areas where helicopters or larger VTOL aircraft would struggle. Another major attraction is its turbine system, which can operate on diesel, biodiesel, jet, A1, or kerosene and can be refueled in less than a minute. The trade-off is endurance. Current prototypes can remain airborne for roughly 10 minutes, so this is built for intense short flights rather than long-distance transportation. In the United States, its ultralight configuration can also avoid many of the licensing requirements associated with conventional aircraft, provided the applicable weight and speed limits are satisfied. The advantages are obvious: extraordinary visibility, minimal structure, impressive maneuverability, fast refueling, and the sensation of riding a superbike through the sky. The disadvantages are equally important, including short endurance, capacity for only one rider, and an enormous price. Pre-orders are currently available at $880,000, placing the Airbike firmly in the luxury territory for wealthy aviation enthusiasts rather than ordinary commuters. Still, its combination of lightweight construction, redundant jet propulsion, and computer-assisted flight makes the Volonaut Airbike one of the most fascinating examples of personal aviation becoming reality, bringing the dream of hovering freely above the ground closer than ever. For anyone who imagines personal flight as something you can literally wear, the Jetpack Gen 3 offers an equally fascinating approach. This ambitious prototype resembles a high-tech backpack, but is actually designed to turn the pilot into the center of a compact flying machine. Its architecture uses 2 duct rotors mounted to a lightweight carbon fiber honeycomb frame measuring only 3.1 meters across, giving the system a remarkably small footprint while maintaining stability. Electric motors provide propulsion, while self-leveling flight assistance uses redundant inertial measurement units and joystick controls to simplify operation. Instead of demanding the same technical skills required to control a conventional helicopter, the system is designed to automatically manage stabilization and allow intuitive pilot inputs. Both tethered and untethered testing has demonstrated promising hovering performance, responsive control, and stable flight characteristics, suggesting a future where personal flight equipment could be deployed almost as easily as starting a motorcycle. The Gen 3 design is especially interesting because its development places strong emphasis on compactness, control, and accessibility. It is designed around a maximum payload of approximately 120 kilograms, a possible top speed of up to 200 kilometers per hour, and an operating ceiling of about 3,000 meters. Advanced composite construction keeps the aircraft lightweight, while providing the structural strength needed for this unusual configuration. Because the pilot effectively becomes part of the aircraft, the experience offers enormous visibility and an almost completely unobstructed sensation of flying through open air. Its electric propulsion also promises quieter operation and no direct emissions during flight, while assisted controls could make the learning process less intimidating. However, the Jetpack Gen 3 is still a developmental prototype, so battery endurance remains a major limitation and additional testing will be necessary before its capabilities can be fully proven in everyday conditions. Commercial availability has not yet arrived, and an official price has not been announced, although the sophisticated materials, propulsion system, and avionics suggest that it will not be an inexpensive machine. Even so, the Jetpack Gen 3 represents an exciting vision of wearable aviation, combining compact carbon construction, automatic stabilization, and electric power into a machine that could eventually allow ordinary adventure seekers to experience personal flight in an entirely new way. For anyone imagining the freedom to move above congested cities without being restricted by conventional aircraft, the Cyclotech Cruise-Up offers a fascinating new approach. Developed by Austrian company Cyclotech, this futuristic air car uses the company's distinctive cyclorotors to create a level of directional control that conventional eVTOL designs cannot easily match. 6 enclosed cylindrical rotors provide 360-degree thrust vectoring, allowing the aircraft to slide sideways, move backward, hover accurately, or stop rapidly without needing to tilt its main body. That ability can improve stability and passenger comfort, particularly when operating in confined areas or challenging winds. The carbon fiber composite vehicle measures 6.7 meters long and 3.3 meters wide, making it about 1.5 times larger than an ordinary car while remaining compact enough for potential use from rooftops, driveways, and suitable open spaces. Large windows positioned around the cabin provide broad panoramic visibility, including views through the front, sides, and roof. Electric motors and batteries are expected to deliver a cruising speed of approximately 150 kilometers per hour and a range near 100 kilometers, making the Cruise-Up especially suitable for short urban and suburban journeys. Its enclosed rotor system also helps reduce noise and protects passengers and nearby objects from exposed moving components while producing zero direct emissions during flight. Another major advantage comes from the 6-rotor configuration, which provides substantial redundancy and could allow a controlled landing if one propulsion unit encounters a problem. Because the aircraft can change direction without relying on traditional banking maneuvers, it can transition from vertical flight to forward movement smoothly while keeping the cabin more level. The technology behind the Cruise-Up is supported by more than 15 years of development, including extensive wind tunnel work and hundreds of demonstrator flights. Rather than chasing extreme speed, Cyclotech is concentrating on practical transportation that could eventually make personal air mobility easier to use. However, the project remains under development, with production currently targeted for the early 2030s. Battery improvements, certification, and extensive real-world testing will still be required before widespread adoption becomes possible. Even so, the Cruise-Up presents an intriguing picture of compact electric aircraft becoming part of everyday transportation, whether for commuting, escaping traffic, or simply exploring the skies with greater comfort and control. If the goal is to enter personal aviation through something more approachable, Frankie Zapata's Zapata AirScooter takes a very different route. This single-seat vertical takeoff and landing aircraft combines hybrid electric propulsion with an ultralight structure, aiming to provide substantially longer endurance without turning the aircraft into an overly complicated machine. A protective composite structure surrounds the open panoramic cockpit, giving the pilot excellent visibility while maintaining a strong sense of freedom in flight. Its computer-controlled fly-by-wire system continuously assists with stabilization, direction, speed, and altitude, making hundreds of adjustments every second and reducing the amount of work required from the pilot. That automation is intended to make the aircraft easier to learn, allowing newcomers to gain confidence after relatively limited training. Its hybrid system pairs a compact combustion engine generator with several electric rotors and is designed to provide as much as 2 hours of flight at cruising speeds close to 80 kilometers per hour, with a maximum around 100 kilometers per hour. That endurance makes it far more suitable for recreational exploration, scenic flights, and extended hovering adventures than many battery-only personal aircraft. Its low weight can also place it within ultralight regulations such as FAA Part 103 in the United States, potentially eliminating the need for a conventional pilot license and greatly simplifying access for qualified operators. The AirScooter also emphasizes redundancy and active stabilization, combining those systems with a rugged compact structure designed to make flying feel closer to riding an advanced aerial scooter than operating a conventional airplane. When sustainable fuels are used, its carbon footprint is intended to remain comparable to that of a normal passenger vehicle. In 2026, the first Zapata Flight Center is opening in the Las Vegas area, where supervised experiences and training sessions are expected to cost roughly $350 to $500. Those interested in ownership can expect purchase prices starting near $250,000, with deliveries anticipated in 2027. Its strongest advantages include impressive hybrid endurance, relatively simple operation, regulatory accessibility, and the excitement of an open cockpit. However, it remains limited to one person, still requires fuel to achieve its extended range, and continues to undergo real-world development and testing. Overall, the Zapata AirScooter could become one of the more practical bridges between experimental personal aircraft and everyday recreational aviation, combining Frankie Zapata's experience with a design focused on accessibility, safety, and pure enjoyment. For enthusiasts who want something considerably faster and more aggressive, Jetpack Aviation takes the flying motorcycle concept into another category with the Speeder. This jet-powered compact VTOL is designed to deliver the sensation of riding a high-performance motorcycle while airborne, using several turbojet engines mounted on a lightweight carbon fiber structure roughly comparable in size to a large motorcycle. Its vertical takeoff and landing capability means it can potentially operate from extremely confined locations, including small clearings and suitable private properties, while its compact construction allows impressive maneuverability. Jetpack Aviation is developing several configurations, from relatively simple ultralight versions intended for recreational use to more powerful variants aimed at substantially higher performance. Recreational models are targeting speeds above 240 kilometers per hour and altitudes reaching approximately 15,000 feet, giving the Speeder capabilities far beyond most conventional personal flyers. A major part of the experience comes from its sophisticated fly-by-wire system, which converts rider commands into controlled flight while automatically assisting with balance, thrust direction, and overall stability. This motorcycle-inspired control philosophy is intended to make the aircraft feel intuitive rather than forcing riders to master the complex workload associated with traditional aircraft. Several compact jet turbines can run on commonly available fuels including Jet A, kerosene, or diesel, allowing rapid refueling while delivering a strong thrust-to-weight ratio. Depending on conditions and pilot weight, expected flight endurance is roughly 10 to 20 minutes. Multiple engines also provide propulsion redundancy, improving the aircraft's ability to remain controllable if an individual engine encounters trouble. The open riding position delivers the unmistakable sensation of flying directly through the air, while onboard avionics can assist with navigation and collision avoidance. With Jetpack Aviation already having significant experience in personal jet flight technology, the Speeder is among the more mature concepts in this emerging category. Pre-order prices begin at approximately $380,000 for the basic recreational version, with limited availability and deposits required to reserve a production position. Its biggest strengths are exceptional speed, high maneuverability, compact dimensions, intuitive controls, and the engineering experience behind the project. The compromises are equally clear. Jet-powered flight remains relatively short, fuel consumption can be expensive, operating noise is significant, and training or certification requirements will depend on the specific model and local aviation regulations. For enthusiasts who want substantially more capability from personal aviation, the Elio Coupe by Elio Flight presents an impressive combination of sports car styling, electric propulsion, and two-seat VTOL functionality. Designed to resemble a high-performance automobile for the sky, This compact aircraft uses several duct fans arranged within a distinctive boxwing structure. That configuration improves lift distribution, aerodynamic performance, and stability, while keeping the overall aircraft compact enough to fit inside a conventional garage, making storage and deployment far more convenient than with many traditional aircraft. Multiple electric propulsion units provide redundancy. While the aircraft is targeting cruising speeds of approximately 320 kilometers per hour and a potential range of up to 400 kilometers, giving it enough capability for regional travel rather than simply short recreational hops. Intelligent fly-by-wire systems are designed to assist with critical tasks such as automated takeoff and landing, reducing pilot workload and improving consistency during demanding phases of flight. Inside, the carbon fiber composite cabin combines a premium automotive-inspired appearance with wide panoramic visibility for both occupants. Advanced avionics are expected to include collision avoidance, continuous flight monitoring, and several layers of system redundancy designed to improve safety throughout the mission. One of its most interesting technical features is the combination of vectorable duct fans and the boxwing configuration, which is intended to provide a smooth transition from vertical hovering into efficient high-speed cruise without sacrificing too much comfort or aerodynamic efficiency. Reservations are already being accepted, with the base aircraft expected to cost approximately $460,000 depending on equipment and configuration. Its two-seat layout, high projected speed, substantial range, compact garage-compatible dimensions, automated flight assistance, and luxury appearance give it considerable appeal. However, real-world performance could be affected by current battery limitations, while the purchase price places it firmly in the premium category. Regulatory certification and appropriate pilot training will also remain important steps before the aircraft can achieve full-scale commercial operation. Overall, the Leo Coupe combines the visual appeal of a supercar with advanced electric aviation technology, creating a fascinating possibility for fast, comfortable, and highly personal air travel. Moving into a much larger class of aircraft, the Pantala Concept H from Chinese developer Panta offers a dramatically different vision of electric VTOL transportation. Rather than focusing on one or two occupants, this ambitious design is intended to carry 5 passengers while combining luxury, high speed, and regional capability. Its 22 electric motors and duct fans are distributed across a pair of tilting wings, allowing the aircraft to perform vertical takeoffs and hovering before transitioning into efficient wing-borne flight. The spacious cabin is designed around passenger comfort, with enormous panoramic windows providing broad views through the front, sides, and overhead areas. This creates an environment suitable for everything from business transportation to family travel and executive journeys. Retractable landing gear further improves aerodynamic efficiency by reducing drag once the aircraft reaches forward flight. Energy comes entirely from lithium-ion battery packs driving high-efficiency electric motors, with the Concept H targeting approximately 300 kilometers per hour in cruise and a projected range close to 250 kilometers while carrying all 5 occupants. Its design has also attracted international recognition through a collaboration with German design studio Kurbos, earning the prestigious IF Design Award. Carbon fiber composite construction helps reduce structural weight while maintaining the strength required for this relatively large electric aircraft, and the distributed propulsion arrangement provides redundancy intended to improve overall safety. Development has already progressed beyond pure computer modeling. A half-scale demonstrator called the T1 has completed both tethered and untethered hover tests, demonstrating stable control and successful transition-related maneuvers. Full-scale development is moving towards certification objectives around 2027. The Concept H offers several obvious advantages, including 5-seat capacity, strong projected cruise performance, useful range for an electric aircraft, quiet operation, and a cabin designed more like a premium passenger vehicle than a conventional cockpit. At the same time, battery energy density remains a major limitation. Certification of 22 coordinated propulsion units will be highly demanding, and final production pricing and delivery schedules have yet to be firmly established. Even with those uncertainties, the Pantala Concept H presents a compelling picture of quiet, zero-emission regional flight that could eventually carry multiple passengers above crowded roads and between nearby cities. For those interested in an eVTOL project that is further along the path toward practical commercial service, the Valo from Vertical Aerospace represents a more mature approach. Developed primarily around air taxi operations and short regional transportation, this premium electric aircraft could also provide technology that eventually influences future private aviation. The cabin is designed to accommodate between 4 and 6 passengers in addition to a pilot, with large windows providing expansive views and sufficient space for luggage. 8 tilt-shift propellers powered by electric propulsion systems handle vertical takeoff before transitioning into efficient forward flight, combining low operating noise with the advantages of distributed electric propulsion. The Valo is targeting a cruising speed of up to 241 kilometers per hour and an approximate range of 161 kilometers, making it particularly well suited to rapid connections between downtown areas, airports, and suburban vertiports without relying on congested roads. A major strength of the program is its emphasis on certification standards comparable to those applied to commercial airliners. Extensive testing, regulatory work across multiple markets, and partnerships with prospective operators are intended to support commercial service around 2028, placing the Valo among the more credible advanced eVTOL programs currently progressing toward real-world operation. Passenger comfort is another major focus, with a modular cabin, premium seating, generous personal space, and an interior designed to feel closer to a luxury lounge than a conventional aircraft. Redundant electric propulsion and sophisticated avionics add further layers of reliability and control. Testing has already demonstrated piloted transition flight, giving the project an important advantage over concepts that remain entirely theoretical. Its strengths include a serious safety strategy, competitive speed and range for an electric aircraft, a flexible cabin, quiet propulsion, and meaningful progress towards certification. The limitations include battery constraints that can become more significant at maximum passenger loads, the fact that the aircraft is primarily being developed for commercial operators rather than individual buyers, and the substantial expense associated with advanced certification and production. Nevertheless, the Valo demonstrates how electric vertical aviation is moving beyond futuristic concepts and toward practical transportation, combining advanced propulsion, passenger-focused engineering, and rigorous certification ambitions to bring quieter and cleaner urban air travel closer to reality. For anyone wanting the excitement of a flying motorcycle combined with the usefulness of a small aircraft, the Silverwing S1 from Silverwing Personal Flight offers an intriguing single-seat electric VTOL in an exceptionally compact form. Its futuristic cockpit puts the pilot in a sporty, racing-inspired position beneath a streamlined protective shell, creating an immersive sensation while maintaining structural protection. The design combines motorcycle-like agility with the controlled flight characteristics of a purpose-built aircraft. A distinctive canard layout works alongside duct electric fans to support vertical takeoff and landing from an area smaller than many conventional cars. Once airborne, the aircraft rotates through a 90-degree transition into forward flight, improving efficiency while reducing noise during cruising. Twin-duct rotors powered by high-density batteries are designed to produce cruising speeds of approximately 140 kilometers per hour, around 30 minutes of endurance, and a 90-kilogram payload. That combination makes the S1 suitable for short recreational flights, sightseeing, or quick trips over congested urban areas. Its autopilot system can provide hands-free assistance, while enclosed electric propulsion helps reduce noise and improves the overall riding experience. The aircraft is also designed around intuitive controls and relatively simple deployment from suitable open spaces. Prototype testing has already demonstrated stable hovering, controlled transitions, and promising flight behavior as the project develops beyond its origins as a TU Delft student initiative and moves toward wider commercialization. Its strongest qualities include an extremely compact footprint, motorcycle-inspired seating, zero-emission propulsion, quiet operation, and a design intended specifically around personal use. The limitations are mainly the approximately 30-minute endurance dictated by present battery technology, its single-person capacity, and the additional certification and endurance testing still required before broad commercial availability. Even so, the Silverwing S1 offers an exciting preview of where highly compact electric VTOL technology could be heading, bringing the freedom and excitement of motorcycle riding into a completely new dimension above the ground. To close out our lineup, the Volar from Bellwether Industries takes an entirely different approach with a futuristic wingless lifting body eVTOL designed specifically for compact urban transportation. Rather than relying on conventional wings or exposed propellers, the Volar incorporates its electric propulsion system beneath a smooth aerodynamic outer shell. This creates a compact aircraft with a footprint smaller than many sport utility vehicles, potentially allowing it to operate in confined urban locations, access rooftop landing areas, and function with far less visual and acoustic disruption than conventional aircraft. The design combines lifting body aerodynamics with distributed electric motors to generate vertical lift, stable hovering, and controlled forward movement, while fly-by-wire systems and autonomous assistance are intended to make operation easier for future users. Half-scale demonstrators have already completed free-flight testing, showing stable hovering, accurate control, and successful movement between vertical and horizontal flight modes. Bellwether is working toward larger versions, including 3-seat configurations and potentially bigger models capable of carrying several passengers on short urban journeys. Target performance is around 140 kilometers per hour, with a range intended primarily for quick city trips rather than long-distance travel. Concealing the propulsion units offers additional safety by shielding the fans while also giving the aircraft a sleek appearance that resembles a futuristic supercar more than a conventional flying machine. Its all-electric powertrain produces no direct flight emissions and promises relatively quiet operation, making it well-suited to the company and Oppo's vision of cleaner urban mobility. The Volar and Oppo's biggest advantages include its compact dimensions, potentially simplified operation, compatibility with dense city environments, and the possibility of advanced autonomous assistance or even future autonomous operation. Those features could make it suitable for both individual transportation and shared air taxi networks without requiring the enormous infrastructure associated with traditional airports. However, the project is still moving toward production readiness around 2028, and current battery technology remains a major limitation for longer journeys. Pricing is also expected to occupy the premium range, potentially reaching several $100,000 once production begins, while certification and full commercial deployment will take additional time. Even with those challenges, the Volar demonstrates an intriguing combination of concealed propulsion, lifting body efficiency, and urban-focused engineering, offering a vision of compact electric aircraft that could eventually make flying across busy metropolitan areas faster, quieter, and far more practical. And that brings us to the end of our look at personal aviation in 2026. Electric propulsion, increasingly capable flight computers, and ambitious engineering teams are steadily pushing these once futuristic machines closer to reality. Whether your idea of personal flight is a weekend adventure above the countryside or a quick trip over traffic, the possibilities are expanding rapidly. Which of these aircraft would you most want to experience? Tell me in the comments. And if you enjoyed the video, remember to like and subscribe for more coverage of emerging aviation and future technology. Thanks for watching, stay curious, and I will see you in the next one.